Have you ever wondered why your computer completely freezes when you open too many browser tabs, but runs perfectly fine when you're just watching a video? The answer is hiding inside a tiny piece of metal sitting in the center of your motherboard. Today, we're breaking down exactly how a CPU works in plain English. Welcome to Bite-Sized Silicon. Behind the smooth interface of your daily tech lies unimaginable complexity. Billions of microscopic actions happening every single second at speeds we can barely grasp. CPU stands for Central Processing Unit. Think of it as the ultimate master chef of a massive restaurant. Every time you click your mouse or press a key, you are handing an order to the chef. Despite the complexity, the core function is surprisingly simple. Imagine one core is like one chef in that kitchen, handling one major task at a time. A single core processor, that's one chef trying to cook every single meal from appetizer to dessert sequentially. But a quad core, you have four chefs. One is rendering your video, one is running background apps, and two are handling your game, keeping everything running incredibly smooth. But how does that chef actually do the cooking? We have to go much smaller. Inside that piece of silicon are billions of tiny microscopic switches called transistors. Think of a room with billions of light switches. A switch can only be turned on or off. On represents the number 1 and off is the number 0. This is binary code. By cleverly combining these simple on-off signals, the CPU calculates everything from simple math to complex graphics, representing everything we see on screen through patterns of ones and zeros. How quickly can these switches be flipped? That is called clock speed, measured in gigahertz. A processor with a 3.0 gigahertz clock speed means its internal clock is ticking 3 billion times per second. That's 3 billion calculations handled every single second for each core. To manage all this, the CPU follows a relentless 3-step loop. Step 1, fetch. It grabs the next instruction from your computer's memory. Step 2, decode. It translates that instruction into those billions of zeros and ones the transistors understand. And step 3, execute. It actually performs the calculations, flipping the necessary switches to carry out the command. Even with billions of operations, fetching everything from the main memory is slow. That's why modern CPUs use cache memory, which is a tiny, super-fast memory pool right on the chip itself. Think of it like the chef's immediate workstation with the most frequently used ingredients, making execution much faster than reaching all the way into the massive pantry. This cache works within a hierarchy. Cache is fastest but smallest, followed by RAM, near the chip and larger but slower, and finally massive storage, where all your files live and is the slowest of all. The CPU gets its info from RAM and storage, but uses cache for the ultimate speed in immediate processing.
So, when your computer handles multiple demanding tasks seamlessly, it's not magic. Your CPU intelligently distributes the workload across its different cores and advanced components, processing millions of instructions per second across gaming, editing, browsing, and everything in between, simultaneously. Modern processors sometimes take this a step further, combining powerful performance cores for intense tasks with smaller, less power-hungry efficiency cores to handle background processes, balancing massive performance with lower power consumption for a smoother, smarter experience. Billions of calculations and switches produce significant heat. Without effective cooling, whether through air or liquid systems, your CPU would overheat and slow down or even break, much like that master chef becoming completely overwhelmed and needing to stop.
So, from billions of transistors flipping billions of times a second to handle calculations in complex loops, distribute across multiple cores, manage cache memory and hierarchy, and battle heat, that is how a CPU, the brain of your computer, powers everything you do every single day. Understanding this doesn't just make you smarter about your technology. It gives you a deeper appreciation for the incredible engineering marvels sitting in your pocket or on your desk right now. If this simple breakdown helped you see your tech in a new light, consider subscribing and dropping a like for your daily dose of tech knowledge. We are committed to making complex tech easy to understand, one bite-sized piece at a time. Thanks for watching Bite-Sized Silicon, and we'll see you in the next one.